Didn't see you there. Come on, let's go. I'm going to teach you the 3 rules of probability. Come on, follow me. 1. 1. 1 or. 2. 2 and. Come on. 3. 3 given. So the first rule we're going to use is the addition rule. This is shown through probability of A or B equaling the probability of A plus the probability of B minus the probability of A and B. This is the overlap, which you have to subtract from the original probabilities. So for this OR example, we're going to show you the probability of one card being selected and it being a king or a club. Now within this, there's an overlap because there's a king of clubs, so we're going to have to take that into account. So we'll write out the formula as probability of king plus the probability of club minus the probability of king and club. So we'll start. So there are 4 kings in a 52 card deck plus 13 clubs in a 52 card deck, and we're taking into account the 1 king of clubs, so we will subtract 1 out of 52. That will give us 16 out of 52, and that simplifies to 4 over 13. So in conclusion, there is a 4 out of 13 chance that we will get a king or a club. Conditional probability is the probability of an event occurring given that a previous event has already occurred. This has to do with replacement and not replacement of the values. This is shown through probability of A and B equals the probability of A times the probability of B given that A has already occurred. For probability of A, so for an example for probability of A and B, the formula is probability of A times the probability of B given that A has already occurred. So for this example, we're going to say, what is the probability of reaching into a bag full of marbles and taking out 1 blue marble, and then after taking out that blue marble, getting a green marble. So there are 2 blue in the bag, 3 green in the bag, and 1 white. This is a total of 6 in the bag. So first we will do the probability of B. The probability of B is 2 out of 6, so it would be 2 out of 6. This is multiplied by the probability of B, or 1 green, given that 1 of the blues has already been taken out. So instead of 6, there are 5. So now all we have to do is multiply through. So 2 times 3 is 6, and 6 times 5 is 30. And we simplify that to get 1 over 5. So there is a 1 in 5 chance of pulling out a blue marble, and after the fact, getting green marble after the blue has been taken out. The next rule we're going to use is the multiplication rule. This rule shows the probability of 2 events occurring in sequence, whether or not they are related. If they are independent, they will not affect each other's probability. If they are dependent, they will affect each other's probability. The formula shows the probability of A and B equaling the probability of A times the probability of B. So for the probability of A and B, the equation is probability of A times the probability of B. This, of course, is saying that the 2 events that will be tested are independent and will not be relying on each other. So for this example, we have a bag of 6 marbles, 2 blue, 3 green, and 1 white, and a deck of 52 cards. Now the question is asking, what is the probability of the person drawing an ace from the deck and getting a blue marble? So the way to do this is the probability of A, which is the 4 aces in a 52 card deck, multiplied by the 2 blues out of the 6 total marbles. So now all we have to do is multiply through. So 4 times 2 is 8, and 52 times 6 is 312, which simplifies to 1 over 39. This means there's a 1 in 39 probability that you will get an ace and a blue.